However, I do not touch detail of kernel programming. I think it is a Haskell Symposium. Then I do not say about detail of kernel programming. However, strongly focus our Reentrance GC for real kernel programming. Proof of the pudding is ET. This is my NetBSD kernel. Okay, pudding. Sorry. I think it's normal sound. I think. However, now word stop. The user size, the space, and the kernel space is also stopped. Everything stopped. And those set breakpoint GC perform GC. It's a garbage collection start point on JHC, Jones Haskell compiler. And continue and stop GC. And continue stop GC and continue and stop many time, okay, GC in kernel space. Okay? Also backtrace interrupt occur and switch to interrupt context and the HD audio intro function is the start. The HD intro function written by Haskell and the function for allocation keep GC. Okay. However, delete every breakpoint and continue. No problem. And also as through top. However, CPU is mostly idle. No problem. Very right. It's my demonstration. Oh, why can't you sleep? Stop. Okay. That's demonstration. Very busy. Okay. 16. Okay. Okay. See? Thank you. So bad. Okay, let's start for presentation. It's my cheat sheet. Okay. You see the demo and will be also following URL and the slide can download the following URL. Okay. It's a demo architecture. Draws the figure first. Hardware kick the hardware kick AJH runtime. AJH runtime get from pool a new context for Haskell run function. Haskell function run while Haskell function running sometimes allocation new sunk from GC heap. Sometimes allocation routine keep garbage collection. And I'll make some running and return to C language. When return to C language AJH runtime, the context is return to the pool. And the boom. It's the demonstration. Okay. It's then by the way, start point. It's a start point. The kernel developer want time. Many people live in user space. However, kernel space people would like to type also. The kernel developer will see, and we should greatest care. It's a kernel design in needs greatest care than application, user space application. Sometimes, of course. But C language is unsafe and messy and not flexibility. Please see. Min kernel bug is a buffer overrun. You know, I think you know. On interface, pointer do not know the far array size, of course. Then sometimes overshoot the area. It's an overflow, buffer overrun. It's a very popular bug. And also, very popular. Minor. I think. Sorry, you are Haskell. But I am C program. Sometimes page fault occur. In user space, page fault is some segmentation fault. However, in kernel space, page fault is this. Okay, can't debug. Sometimes can't debug. Sometimes can't reproduce. No debugger. Sometimes ops message. This is hard. Easy to easy to produce fault in kernel space, but user space are not easy. Okay. And kernel bug 3, we sometimes use weak type. Kernel program sometimes many times use weak type. Let's see. NetBSD kernel used weak type. Void asta. Do you know void asta? Void asta is a pointer have no meaning. Anything can cast to void asta. It's a very weak type. But it's a kernel developers have no other choice. Because C language have no flexibility, then they need to choose the void astas meantime. Then it is our project MetaCP. MetaCP is aimed to provide Linux-like operating system designed by Sondheim. However, today. Empty code. We want to use MetaCP OS for daily desktop users. Daily desktop users is your type to it's a notebook, it's your phone, it's your Apple mark, silver plate. The OS would like I would like to the OS to shape it. Okay, and we have surveyed the many functional language, Haskell, Okabe, Milton, SM#, something like that. The after I will say today. This character is us. This wave is time. The race. For building operating system, there is two ways. One is many people choose from scratch. Sometimes SEL4, SEL4, sometimes house. Do you know house? House is from scratch operating system. The other way is rewriting existing kernel. When from scratch, we should make everything. Your browser, your Flash player, or something like compiler, or web browser and something like everything you should build and you should create so much time. However, focus to the kernel is sometimes easy, sometimes easy. Rewrite. However, we have the fully strong type kernel, the rewriting way. We choose the rewrite way, choose the metatypic project. What time is it? And Snatcher, do you know Konami's video game, Snatcher? Oh, so great! You are today. I think you should enjoy. Snatcher, on Snatcher, Android society replaces the human society. My Android, hey, happy! Get skin and my skin. You are not real. I become you. It is a snatch. Okay. However, the C-language implementation have an interface. The interface and the Haskell language, the skin get, and C-language implementation like action. やべえ時間が。Snatch driven development is such as choose existing Linux-like kernel and choose the simple module and rewrite it with strong type and the rebuild and can test or using and next module. Forever, everything will be strong type. The snatch. Why we choose JH Haskell compiler? Why? It's a simple survey. This is a Hello World programmer's feature. It's a binary size. Hello World program binary size and undefined symbols and the dependent library. Glasgow Haskell compiler many dependent libraries. Of course, it's for many features. However, the JHC or ADS2 is a very small, depend on POSIX architecture. However, Haskell language is a good flexibility. Then we choose the JHC for first iteration. やべえ時間やべえな。Linux operating system need reentrance. That's all. We choose rewrite method. Then we should build Unix-like operating system architecture. But Unix-like operating system need reentrance. Skip. What is reentrance? It's a subroutine. This figure says subroutine X is not reentrance. Start subroutine X and switch to the switch which is interrupt, hardware interrupt. Then we call subroutine X. However, subroutine X weight low. It is a deadlock, but self-deadlock. It is simple, not reentrance example. Okay, next, how do we get reentrance in C? Why C language can save reentrance? It's a simple way. C language can shape isolated context. This context and this context is isolated and not depend on. Then can switch. It's easy. It's also do this. Okay. C language context of what is C language core? It's a CPU registers and C language core stack. If you replace these, then the other context run. Okay. Problem. Interrupt and GH is not friend. Not friend. Main context. Please imagine main context running the garbage collection, not end. But however, interrupt occurs to the new context. And new context would write to GC heap, however, not yet finished by garbage collector. Then can't use GC heap. It's a problem. What is the root of problem? It's a simple. It's a in Glasgow Haskell compiler case. Glasgow Haskell compiler have only one context. Then not split, not isolated context. Glasgow Haskell. Of course, no, not only Glasgow Haskell compiler, but also Okabe, something like language. Also. Then Glasgow Haskell compiler GC and the binaries is not Reentrance. Okay, the time is very fast. 3 minutes. How we can fix this problem? Then we Metasploit project redefine the Haskell context. In Glasgow Haskell compiler, this context is the same. I think if you should read FFI manual. Then, however, JH our customized JH Haskell compiler is a split these compilers. Then, how divide this? It's a simple. The word, the localize GC heap, then isolate get. Then we can get isolated context. どこまで急いだらいいんだろう。まあいいか。ちょっと見てみよう。Haskell, what is Haskell context? Its name is context local heap. What is the context on context local heap? It is the simple. The CPU registers and C call stuff. It is same as a C language. Plus, and GC information. Arena is meaning manage GC information and the GC heap. You know, and GC start is GC root. If you replace these data, the others, then switch Haskell context. It is JHC thinking context local heap. Okay. やべえ時間が。Haskell context life cycle is this. Skip. and what is result is meaning GC is the contexts are on GC. Then we can thread safe and reentrance, parallel running, and concurrency. Of course. However, these contexts canもう無理だな。It's a benchmark. It's a やめよう。Conclusion. We can Unix like OS in Haskell, and we can reentrance GC with concatenate local heap, and we can concatenate local. We can apply concatenate local heap for the other language. Okabe? Yes. Glasgow Haskell compiler? I think yes. That's all.
Question in the back.
First of all, awesome talk. Thank you. So can you elaborate more about what what it would take to sort of enable GHC to have that sort of, to allow GHC to have that sort of context local heap architecture? Or what is it you're thinking in terms of that part? I'm curious.
What do you mean?
For the context local heaps for GHC, what are your thoughts on that? I'm curious.
GHC. Context local heap, simple idea is a pack plus the GHC heap. Then GHC decide the context connect context to context with binary interface. Easy. You just do it.
Also, that was a fantastic talk. Thank you. Have you looked at rump kernels in NetBSD? Rump kernels?
Rump? I don't know. Do not use rump and the native kernel.
Because they provide an easy way to test your device drivers in Unix user space before putting them into a kernel. So you might find it easier to develop.
Yeah, easier. However, rump is a fake kernel. Okay, then not my scope.
I'm sorry, I didn't catch that.
It is not my scope. For rump, user space driver is a performance is a less, and the main thing is a cheat. Then out of scope.
You're not cheating. This is agreement.
So how do you handle laziness? Does that run into weird performance behaviors? And the same question for garbage collection. How do you avoid trouble with garbage collection policies?
Yeah, you are just good question. Yeah, our compiler is very buggy. Then buggy and many a long lazy chain is attached. The many the code eat many stack. Then but the performance but will be getting bad performance and bad memory space. Then in kernel space today in kernel space lazy evaluation is bad idea. However, in future maybe not.
So this is great, but you didn't show us any code.
You
didn't show us any code.
Yeah, so bad code. do you so bad code? It's a copy from C language. Sorry. なんだっけな。Dev PCI HD audio HS. It's a wow, messy. It's a interrupted. However, do you see the mutex enter is hits the mutex lock start and mutex exit is meaning mutex unlock. So very dangerous for deadlock. However, is not before cleanup code is a map from simple map from C language. There's sometimes with restructure you can see good clear code. Okay.
More questions? So I have one more question.
Yeah.
So I understand that you create a new heap each time you re-enter. So you're creating a new heap. What if you need to share data? What if you need to look at data?
Also good question. Yeah, こっちだった。これだ。This is first allocation GC heap. The first allocation heap size tuning 1 megabyte. Okay. But then and every life cycle is enough 1 megabyte for running kernel space because event driven, very short event driven. Then 1 megabyte is a good for Haskell code in kernel today.
So the question was, what happens if you have data in the heap that you are calling from?
Calling from?
Suppose you have a top-level binding, a top-level cap. I'll take it offline. It's okay.
Sorry. I think I can't understand.
Yeah. Thank you very much.